All right, this will just be a quick video on derivative notation. There are different ways to define a derivative or to express a derivative. So let's talk about the first derivative. And in this case, we're using the fact that y equals f of x, and you'll see why. But in class, we described this notation. This is f prime of x. That represents the derivative. Or you could do it in terms of like x and y, not function notation. So you could write it like this right here, y prime. So f prime of x or y prime. These are called the Newtonian or the Newton notation. We have the Leibniz notation, which I'll do here in blue, which looks like this. So this statement right here, dy dx, is the Leibniz way of saying derivative. These all mean exactly the same things. I figured we just want 20 different ways of doing it to confuse you. Actually, no, there's real reason for that. But here is some more of Leibniz notation. You could say df dx, or finally you could say d dx of f of x. And the second derivative just follows from that. Basically the same patterns, just to denote the second derivative. And it looks like this. Second derivative of f is f double prime of x, or y double prime. With Leibniz, it gets a little bit more confusing. You put some 2's in places, but this dy dx, in the second derivative, you write d squared y over dx squared. And then you do exactly the same thing with this second notation. And then in the final notation, you probably could guess what this is. It's just d squared over dx squared f of x. You'll get very used to each of these notations. They're just used differently. And again, just so you know, this first was developed by Newton, and this second set was developed by Leibniz. And if we were in class, I'd go off on why this is, but basically Newton and Leibniz both developed the concepts of calculus separately at almost exactly the same time, and they use two very different notations. In fact, you're going to see throughout this class and future calculus courses where one of these notations is the absolute best. Just so you know, for when we get rocking later in class, my absolute favorite is the Leibniz, and there's a very specific reason for that. That dy dx is very clarifying, and you can use it as a fraction in a crazy way, crazy useful ways that we'll see soon.